Hi, this is Swapnil Bharti, and we are here at KubeCon in San Diego. And today we have with us Evan Gilman, your staff engineer at Untitled. First of all, welcome to the show.
Thank you. Thanks for having me.
I'm just curious, can you tell us a bit about what does Untitled do and when was the company created?
Sure. Let's see. The company was created 2.5, almost 3 years ago, and we focus on solving this challenge of identity, interoperable identity, which is what the Spiffe and Spire projects that are focused on, the ones that I work on. And so Sightail, number one, kind of drives those projects, interoperable identity between different cloud providers, different types of platforms and things like this. And then build solutions on top of that to extend it to speak to legacy hardwares and things along those lines.
Can you explain what is interoperable identity?
I spent a lot of time thinking about the best way to describe this, and the one that I kind of keep coming back to is similar to the way that passports work. If you look at passports from different countries, they may be slightly different, but they're all kind of the same. They're all like the same size. They all have a picture in kind of the same spot. They have the same funny looking barcode at the bottom, so on and so forth. And when you show up at a country and you show your passport, they know how to read your passport no matter what country that passport is from, right? So that's what I'm talking about when I say interoperable identity. When you think of the country analogy, that might be like a particular type of software stack or a particular company or something like this. But these identities that exist within those silos can work between them.
So we look at multi-cloud, hybrid cloud, people are running their workload on-prem. So does it work across?
Absolutely. So this when you have these kinds of multi-cloud and hybrid deployments, that it raises this fundamental challenge of how do you secure communication across those boundaries, right? And this is exactly the problem that these projects aim to solve. If you think about running something in AWS, for instance, maybe you'll use an AWS IAM role in order to say what an instance should or should not have access to. But as soon as you're communicating from AWS to GCP or from AWS to your on-prem infrastructure, right? Those things do not understand what IAM role is. That is an AWS-specific notion, right? So this concept of interoperable identity and the problem we're trying to solve is exactly this. We are bringing what we call a platform-agnostic identity, an identity that is not specific to a cloud provider or a platform, and it's not specific to a kind of technology. It kind of raises the playing field, if you will. So when you talk across those boundaries, you don't talk in AWS specifics or GCP specifics. You talk on the Spiffe level. And this Spiffe level gives you what is sometimes referred to as this kind of secure dial tone. So you pick up the phone, it rings the other side. It doesn't really matter what platform it is or where it's running or anything like that. The Spiffe authentication occurs, and you get a nice little layer of encryption and some authenticity assurances as well.
I will come back to Spiffe and Spire. I'm curious about, because when you look at cloud endeavor, we talk about zero trust, which literally means don't trust anybody whatsoever. Can you first of all define what is zero trust? And you also wrote a book about it.
Yeah, so zero trust is, it's a little unfortunate, it's become quite the buzzword, and everyone's got a different definition for it, It's also extraordinarily large in scope. The book that I wrote is called Zero Trust Networks, and we named it explicitly Zero Trust Networks for a reason, because we are taking this philosophy and we are applying it to network infrastructure, service-to-service communication. And to me, what that means is a Zero Trust Network is saying, okay, we are not going to rely on or trust the network to do anything that we expect it to do, right? We remove all the security functions from the network, and we don't make any assumptions about what should or should not be allowed based on IP address or something along those lines. They've been historically fairly manipulable. So instead, we build systems in such a way that doesn't rely on the network to deliver trustworthy information. And we use protocols and strong authentication and authorization to try to mitigate any kind of funny business that might happen on the wire. It also mitigates what we call lateral movement. So, if a neighbor is compromised, just because you're attached to the same network, it should not mean that you should gain access that you would not have otherwise. So, to me, the definition is, strong authentication and authorization pretty much everywhere, encryption and confidentiality pretty much everywhere. And then from there, it kind of falls out all these different patterns and ways to actually accomplish that, because it turns out it's like a fairly hard thing to do.
So you wrote a book about zero trust. What is Citel doing to actually?
Sure. It's the book has been fairly popular and successful, but I look back on it with there's a bit of a tinge of failure in my mind, and that is because we wrote this book and we talk about all these fancy things and this different way to think about building systems, but the reality was at the time that there was not very much software out there that you could use to accomplish this kind of architecture. The stuff that I had worked on and my co-author and some other folks that helped us with the work have built these things, but they build behind closed doors and the software is not available. So it was a failure in that kind of felt like we dump a bunch of work on folks. We say, hey, here's this way to think about it. You should think about it like this, but oh, by the way, you can't even go buy this stuff, right? So what we're trying to solve at Citel is to provide softwares which you can use to arrive at these architectures. If you're going to say that you do this strong authentication authorization everywhere, then you can't really do that without some notion of identity. If you're going to say Alice can talk to Bob, who is Alice and who is Bob? And how do you name these things, and how are those names expressed, and how are they proven, and all of this kind of stuff? That is kind of where we are spending our time and focus. And so I see it as, in terms of the zero trust picture, I see it as extraordinarily foundational. You can't really do any of the things that you need to do in order to accomplish zero trust architecture without having a strong notion of identity. And I mentioned the AWS example before. There are notions of identity out there. This is not a new thing, but they tend to be tied to a specific platform or technology, right? So what we're trying to do is we're trying to enable this kind of foundational base layer that can go wherever your software goes. So it is not tied to a particular environment.
Awesome. You did talk about it a bit, but I'm curious to understand the two projects, Spire and Spiffe. Can you talk in detail? What?
Yeah. So I gave the passport analogy previously. That's kind of the Spiffe part. Spiffe, so somewhere there is a standard actually that says the passport should be shaped like this, and there's a Spiffe specification that defines a similar thing. It says, here is how you identify a workload. Here is what the name should be formatted like. Here is the shape of this document, and here is how you validate that document, and so on and so forth. So Spiffe really is just this set of specifications, and the end goal is to enable this interoperable identity, right? But that means that it's just a set of documents. It's not really a software. That's where the Spire half kind of comes in. The Spire is software implementation of the Spiffe specifications. So if Spiffe is the passport and Spiffe is the way to know the passport is real, then Spire is kind of like the passport agency, right? Like, where does this passport come from? Who gives it to you? How do you get it? And how do you do that in an automated fashion? So Spire implements these Spiffe specifications and enables workloads and services to get these passports as soon as they boot in a way that is very reliable, scalable, and very, very highly automated. Part of the Spiffe specification set deals with what we call federation. So when you talk about identity, usually there's this centralized authority which is issuing these identities. But different companies have their own authorities. Maybe different software stacks have their own authorities. And there is a need to be able to bridge these gaps. When somebody with one color passport talks to a workload with a different color passport, how do you know that passport is actually valid? Like, you might know, hey, all the ones of my color are valid, but how do you know the other one? So this is what we call Spiffe federation, and it is the swapping of these cryptographic keys, these public cryptographic keys, between these kinds of domains, what we call. And so doing this allows you to have different identity providers, but allow workloads and other identity providers to validate your identity that was issued by someone else. One key thing that key design principle of Spiffe federation is that it is compatible with what we call OIDC discovery, which is a similar identity federation spec, but is more focused around users. We've kind of built on top of that to make some affordances to make it usable for server-to-server, service-to-service communication. But because it is compatible in this way, any existing OIDC works can take advantage of this. So that might mean, for instance, that I'm able to pass one of my Spiffe identity documents to AWS, and AWS is able to validate it using this OIDC Spiffe federation mechanism and turn that into something that AWS knows about. So it allows you to build powerful abstractions to say, like, this workload should have access to this S3 bucket, but because the identity we're using to do that is platform agnostic, the calling workload can be in GCP or on-prem and still access the S3 bucket the same way that you would in AWS normally.
Can you talk about the governance of Spiffe and Spire?
At the very top level, we have what is called the Spiffe Technical Steering Committee. That is myself, another member of Cytail, and a few other folks, including Joe Beta from Heptio, now VMware, and some others that have been around from the project in some early days. Those folks are kind of the folks who keep a tab on the strategic direction, but are relatively hands-off from a day-to-day perspective. Below that, we have two groups of maintainers. One group of maintainers that is concerned with the Spiffe specification set only, and another group of maintainers that is concerned with Spire only. All of these levels, TSC and the maintainership for Spiffe Spire, are a quite healthy blend of folks from Cytail and other organizations, including Uber and Google and so on. So we try our best to keep things neutral. And the Spiffe Spire projects are a member of or CNCF projects, so precisely for that reason, to keep things neutral. And we do our best there's quite a thriving community around it. We do our best to kind of corral all the concerns and make sure that we have what we consider general solution for this problem.
And what is the cadence of these projects released?
So Spiffe doesn't really have releases, so to speak. It's more of a set of documents and specs. It's relatively stable, doesn't change very much. So we don't have any kind of notion.
You don't change the specification every
Yeah, it would be very hard to follow if we did. Certainly new ones are being introduced, but we try our best to keep some stability there. On the Spire front, we do usually like monthly releases, and we do major release once every few months or so.
So can you talk about what was some major, either highlights or features of the latest release?
Let's see. One really cool thing the latest release can do is it integrates with the AWS private CA manager. So if you have Spire deployment that is living inside AWS, you can use this to protect the signing keys for these identities. These identities are cryptographically backed, so there's a key that is used to sign these identities. And one of the hard parts is securing that key, right? So being able to bury that key inside this AWS service, which is backed by hardware protection, is one cool feature. We spent a lot of time also working on scalability, operational safety, stuff along those lines, version compatibility guarantees. Few releases back, we support now like Envoy. So Envoy can just speak directly to Spiffe and get certificates, and those certificates can be rotated transparently without any downtime or anything like that. We also have going back to kind of scalability concerns. We spent a lot of time on different ways that Spire can be deployed, and one of those ways is what we call Spiffe Federation, where you can kind of peer different identity authorities together, whether they both be Spire or some other implementation like Istio. We've also spent some time working on a feature called Nested Spire, which allows you to have multiple Spire server clusters that form a tree and kind of chain up to each other. And those two things in combination give a lot of flexibility in terms of architecting for failure modes and failure domains, and also architecting around like different security domains.
Can you talk a bit about who is using Spiffe and Spire, or what is the...
Yeah, the biggest adopters now are usually like large tech companies, and they have deployments into the tens of thousands of servers. We're seeing a lot of traction also in financial and healthcare services. All kind of folks who, this is a pretty big concern for them, this access control and confidentiality, authentication, those are things that for them is very, very important. So the folks that are most active tend to be from those verticals. There's a lot of interest outside those verticals as well. But I think that the early adopters tend to be on that front.
Are there any use cases where you do see that, they should take it seriously?
Yeah, big time. I think this is important for everyone, and I think there's just a level of effort consideration. Like somebody, I may think it's more important, they may think it's less important. They're willing to spend much less time worrying about it than I'd be willing to spend. Of course, there's a business decision to be made there as well. But at the end of the day, I think what it's really going to come down to is just how can we make this as easy as possible, right? If we can say, hey, push this button and get security, that is like the holy grail, So absolutely there are folks out there who number one, like might have some idea that they need it, but don't really have burning desire. Or number two, have no idea at all, in which case there's a lot of educational awareness stuff that I work a lot on that front. So it's giving conference talks, it's writing blog posts, it's showing folks that this problem exists, that they have it. And it's also about making it as easy as possible to solve. And the Envoy integration I mentioned earlier is a big step in that direction, because it allows you to kind of pick up these security bits without necessarily like changing your application or doing anything that's like too invasive.
Just one more question before we wrap this up is like we are at the end of the year, 2020 will soon be walking into 2020. What are either some trends or some concerns you have that you think the community should focus on next year?
I think right now the biggest concern that we have going into the next year is kind of on that make it easy to use front. That I was describing before. And when I say that, I don't necessarily mean make the software easier to operate. I mean, I think that we have that to a large extent today. What I more mean is provide detailed examples, documentation of how to solve different use cases given the software, how to configure it to solve those use cases. Very, very kind of clear-cut guidance. We have a lot of flexibility and features built into the software, which are not necessarily, we don't have like conceptual guidelines that can teach people how the internals are working and stuff like that. So I think starting now, like we've already kind of started this push, but certainly going into the next year, the biggest concern will just be getting folks to help us with documentation, getting folks to help us kind of like button everything up and make the experience really easy to pick up for folks who might not necessarily like want to get in the weeds with it, but they just want it to work.
Evan, thank you so much for sitting down and talking to me and explaining what Spiffe and Spire communities are doing. And I look forward to seeing you again at some point in the future. Thank you.
Of course, likewise. Thank you for having me.